Hey, it's Brent with Lykins Motorsports. Thought we'd do a little bit something different this week. Wanted to go over my top 5 favorite engine recipes. So these are all combinations that I have kind of researched and built, and just to see what they did, and we're really pleased with the results. So number 1 is a 311 cubic inch small block Ford. So this block, the foundation of this block was a later model Ford Explorer 5-liter block, 302 block. So these are notoriously known for being kind of weak and wanting to split in two, basically. So the first thing we did before we did any machine work was to use some block filler and basically fill the block all the way up to the bottom of the water pump holes. Once that was done, we did our normal gamut of machine work, bored and honed. It was a 4060 bore size. Line honed the mains with ARP fasteners and squared the decks up. We also tapped the holes in the top of the block, the oil drains in between the lifter bores for vents, and that kind of helps keep the oil off the camshaft a little bit. The rotating assembly was an Eagle crankshaft, steel crankshaft. The rods were some R&R aluminum rods. So with the shorter stock stroke, it's easier to fit those big old fat rods in there, but you can see where we still needed to notch the bottoms of the cylinder bores for those to clear. The pistons, you could see them in the first photo that I showed, were custom Racetech pistons with some vertical gas ports in the event that we wanted to add a vacuum pump. Those pistons were extremely short, so they were 0.990 on compression height, and those rods are a little bit longer than the normal rods. You can see we used some ARP main bolts, and the timing chain was a Coy's billet timing set to go with the billet core solid roller camshaft that I use with this build. Camshaft was really rowdy, pretty aggressive lobes, which helped make some of the horsepower and torque that we saw with the engine. Believe it or not, the lift was down around 550 lift. On the cylinder head side, we used a set of AFR 185cc heads. No port work was done. We used those out of the box. That's how good these heads perform out of the box. I did order them bare. They come with 8mm valves out of the box, but we used our own special spring package, and it takes a little finagling with these heads because as you can see, the spring pockets are not a large diameter, so you have to use a smaller valve spring, which is kind of what I like to do anyway. So a smaller valve spring and a smaller retainer makes for less valve train weight. You can see the spring set up somewhere around that 1770 mark. On the top side, we were able to use some Jessel rocker arms, very high quality individual shaft mount rockers, and believe it or not, we were able to squeeze in some 7/16 heavy wall push rods. So push rods for a Windsor block with link bar lifters somewhere vary on the length somewhere around in the 6-inch range. So 6 inches long, 7/16 diameter. They look like little oak trees actuating the valves. Up top is a Victor Jr. intake manifold. This particular manifold was ported by Joe Crane, well in excess of what the cylinder heads would handle. For the rest of it, we just fitted it with the normal parts that we like to use: MSD distributor, aluminum water pump, power bond, harmonic balancer, new timing cover, Mylodon oil pan for a Fox body, and I think we used a high pressure M68 milling oil pump. Some tall valve covers with the logo laser etched into them, and a 2-inch super sucker. So let's look at the dyno results and listen to a dyno. So this little engine made 535 horsepower at 7,400 RPM with 454 pound-feet of torque to back it up. So a lot of special camshaft work and everything going into this engine. Believe it or not, it was on a 100 intake center line. So all the guys that you hear saying advanced cam timing won't let an engine pull, that's kind of not always the case. So a lot of torque and a lot of RPM from this guy. Engine number 2 was our 352 Dyno Mule Project Junkie Junk JJ. So Project Junkie Junk was an engine that I found on Craigslist. We paid $200 for this guy, so it was a good bang for the buck. We were able to use the block, the heads, timing cover, and a lot of other parts. It originally started out as kind of just a fun thing to do. Had a buddy in from Nebraska come to dyno some engines, and we thought that we would just throw this on there for giggles, see what kind of horsepower it would make, and then the project just slowly got out of hand. So that was a blistering 4,500 RPM pull, and I think around 190 horsepower. I documented all this on the fepower.net site. We actually tested some other intake manifolds and carburetors, and by the end of that dyno session, we were making, I think, 260 horsepower with a 4-barrel intake and a Holley 650 double pumper carburetor. So after we did that, it was time to disassemble and check and see what the inside of this engine looked like. It was a cruddy, gunky mess, as you would expect from a 1966 engine. Everything was original in it: cam, lifters, bearings, whole 9 yards. We then deviated a plan to, not deviated, that would be separated from. We devised a plan, that's a lot better word. We devised a plan to do multiple iterations of testing with untouched cylinder heads, ported cylinder heads, and a plethora of intake manifolds. So this engine finally ended up as about a 10 1/4 to 1 compression with a solid roller camshaft and T&D rockers, and with a FE-Power intake manifold adapter with a Y-end 351 Cleveland tunnel ram on top with two 660 carburetors. And we ended up at about 530 horsepower at 7,200 RPM. Pretty nice for a 352. Engine number 3 was a 390 Ford FE. Pretty unique combination: ported Cobra Jet heads and a tunnel wedge and a very high RPM hydraulic roller camshaft. This engine started out with a factory 390 block. We did a lot of work to the block to make it stable for high RPM stuff. We did some bronze lifter bore bushings, reused a factory 390 crank, put some Molnar rods in there, and some custom Racetech pistons. You can see that they were a little bit of a dome. Used basically just a lot of factory parts, factory block, factory crank, timing cover, that sort of thing. For the cylinder heads, these were C8 OEN Cobra Jet heads. Had these ported, and we put some conical beehives for springs. Valves were custom SI valves, if I remember correctly, 7mm on one side and 5/16 on the other, intake and exhaust respectively. So lightweight valves, lightweight spring package, a good flowing cylinder. And then on the top end we used some Lykins Motorsports non-adjustable roller rocker arms to keep everything light, precision oil pumps, stands and end stands, and some, believe it or not, factory springs in between the rockers. On the bottom side we used a Mylodon oil pan and just our standard run-of-the-mill FE parts there. So the camshaft was a custom hydraulic roller. We used some Morel short travel hydraulic roller lifters and a tunnel wedge intake. So here's the 542 horsepower at over 7,000 RPM dyno. Engine number 4 is a 434 cubic inch Cleaver, which means it's a Windsor block with Cleveland heads. And unfortunately, all my pictures for this build were on PhotoBucket. And what a wonderful company PhotoBucket is that you can't even access the photos that you put on there. So we'll just tell a story about what went into this engine. It was a Ford Racing Boss Block 9200 deck. We fitted that block with some roller cam bearings and then a Callie's crank and some Manley rods and some diamond pistons. So we ended up with a 13.5:1 compression short block. For the top end we used some CHI 3V 208cc cylinder heads, had those ported. They ended up somewhere around 260 cc's and almost 400 CFM. On top of that was a CHI 3V single carb intake, and we used a Super Sucker 4150 to 4500 carburetor adapter with a Quick Fuel 1050 Dominator carburetor. Camshaft was a fairly mild solid roller camshaft at around 260 degrees at 50 thousandths duration. Lift was almost 850 lift, but this engine with a vacuum pump managed to pump out 777 horsepower at only 7,000 RPM. The customer decided to put this in a 69 Mustang. Also decided to put it in a class with 10.5-inch tires, and decided to use a Power Glide with a 1:5:6 first gear ratio. So engine was pretty hamstrung at the beginning, but he was able to nail down some 960 ETs at 141 miles per hour. So the package was really wanting to come on strong. Just needed a little bit more help on the bottom end. The number 5 combination that I really like to do with the big block Ford stuff is the 556 cubic inch. This is for sled pulling applications, and we'll get into that now. For these builds I like to use the Eliminator blocks. They are pretty much bulletproof. They come in several flavors. They all have priority main oiling, kind of like a Windsor, not at all like the factory 429, 460 blocks. So these particular blocks much larger bore size. This particular engine was a 600 bore, and stroke was about 180. We use Bryant cranks and Oliver rods and diamond pistons. These are, of course, dry sump type engines. And with the chamber size of the profiler heads and the pistons, you don't have to use a dome, and you can get about 15 to 1 compression. These run on usually C25 fuel. So the camshafts are just flat out huge for this size engine, and for the peak horsepower RPM that we generally shoot for is anywhere from 8,500 to 9,500 RPM. So you can imagine the durations are way up there. Lobe separation angles are typically between 118 and in the 120s on a lobe separation angle. This particular camshaft that you're looking at right here is made for a 937 diameter lifter, and I believe the gross lift at the valve with this cam was about 950. So all of your valve train has to be set up for that, including valve spring, loads, rocker arms, push rod diameters and thicknesses and everything. Jessel gets the nod for the rocker arms. Valve spring loads on these dual springs. We're actually using dual springs instead of triples. They're 1/500 diameter, and seat load is about 400 pounds. Open load is a little over 1,200 pounds. Here you can see pretty much everything else that goes on with these engines. They are dry sump. That's a big 3-gallon oil tank right there in front of you. Two 1450 CFM Braswell carburetors mounted to a custom sheet metal intake with some shear plates underneath. NMSD cam drive distributor, that sort of thing. So these are really high-end engines. This particular engine here made a little over 1,200 horsepower at 8,500 RPM. And if you are ready to hear the dyno pull, then here you are. Alright guys, just wanted to throw this up there for something different for you all, and hope you guys are having a good week. I appreciate everything that you do for watching and for commenting, and maybe this will encourage you to get out and try some of your own combinations. You never know what you'll come up with as far as horsepower and torque. You may hit a combination that really works well. So I hope you subscribe and like the video, and stick around for more stuff. Have a